fill out one of our comment cards. They'll be right on the table outside where you checked in. If you could just let us know how much you love this program so we can keep awesome things like this coming back to Woodneath. Now I'm going to turn it over to our mad scientist.
Good morning, everyone!
Good morning.
Good morning!
That is kind of okay over here. That was awful. Good morning, everyone! Much better. My name's Eric, the engineer, and I'm with Mad Science in Greater Kansas City. We do programs like this at libraries and schools all year round, summer camps, and all kinds of good stuff. So, if you are interested in what we do with robot camps, and rocket camps, and all that kind of stuff, look us up at Mad Science GKC for Greater Kansas City. On the old Googles will come right up. You'll see what we're doing all year. You could also ask me, but I usually don't know. You can ask that man there too. That's Dave, so you can go ask him about it too. Today we're going to do a show all about different kinds of science and how to build a better world. But before I get started, I have 3 really quick mad science rules to go over. The first one is there should only be one mad scientist talking at a time. It can be me, but it doesn't have to be. If you have a question, or if you know the answer to a question I ask, you just raise your hand. And I call on you. You could be the only person talking. We'll all listen to each other and learn as much as possible. I will learn stuff too, so I will listen as well. The second mad science rule is for people who get to come up here and help me during the show. And some of you will get to help me. But don't touch anything I have up here unless I tell you you can, all right? Nothing. Some of it can get broken and that will make me sad. Some of it's a little dangerous that might make you sad, so don't do it. Don't touch anything. And the third rule is only 2 words long. It's the easiest rule, and it's my favorite rule actually. It's have fun, all right? So we're going to do some awesome science experiments up here and we'll have some fun. Now I said this show is about building a better world. Does anybody have any idea how science might build a better world? I saw your hand first. Yes, young man. How might science make a better world?
Maybe growing grass and trees.
Oh, helping to grow grass and trees and crops. There's lots of crop science and helps feed us. Yeah, what do you think? Oh, we can use science to help animals? No. Oh, to make butterflies. I'm not sure if we can make butterflies yet, but there are people working on it. Excellent. So we're going to do some science up here. Some of these experiments you might have seen before. And that's okay, because science takes one experiment and we learn things from it. We can make it bigger and better and more awesome and learn different things using the same experiment and building on it. So we're going to do a lot of science here, and some of the stuff you might have seen before. It might be kind of small. And then we're going to do it bigger and better and more awesome. And I'm going to probably ask you how you can make it even bigger than what we do here. So you might be thinking about that. So, to start this off, what does it look like I have here? Yeah.
Tape.
Tape, maybe. Yeah, maybe it looks like packing tape or something. What do you think? Paper. Does it feel like paper? No. Feels like weird paper, maybe. It's like tissue paper. This is actually tissue paper, very thin. Sometimes you can pack it in presents and things like that. I also have a barbecue lighter here. Now, before I do this, do we play with fire at home? No, because fire can be dangerous because it will spread anywhere there is fuel and oxygen. And since there's fuel and oxygen just about everywhere on Earth, it can be dangerous. So, what might happen if I were to touch this flame to this tissue paper? What do you think? It will disappear. Anybody else? What do you think? It'll burn up. Excellent. It will burn. Will it? Would it melt? Does anybody think it'll melt? So maybe it could melt. What do you think? Oh, it'll turn brown. Maybe it'll turn into a different color. Excellent. tissue paper. Oh, it does burn. Oh, it burns very fast. And it turned into some black thing. It almost all disappeared, but not quite. There's some ashes and things there. So, it did burn. Many of your hypotheses were correct.
Actually, I'm excited.
Yeah.
Oh,
Now, a hypothesis, that's kind of a fancy word scientists have for guesses. Some people said that it might turn brown, or it might disappear, it might melt, it might burn. And we tested that by doing an experiment. What does it look like I have here?
Another
Paper! What does it feel like? Does it feel like paper? It looks like tissue paper. It looks like the same stuff, right? So, when we burn this, what's going to happen? The same thing! What do you think? It'll disappear! It'll turn to dust. Could it explode? Yeah! No! Hold on. It explodes. Oh. That way I'll be okay. My eyes will be okay. The rest of me will be gone. Alright. So we're going to do the same experiment. We'll see what happens with this. It looks and feels like the same thing. Did the same thing happen? No! The same thing didn't happen. Even though it felt like the same kind of paper, it really wasn't. The first one was regular tissue paper. That second one is called flash paper. Or who likes to learn really long words? Alright, we're going to learn a long word. Scientists call flash paper nitrocellulose. Yeah, I think we should try to say that. Nitrocellulose. Yeah, excellent. Nitrocellulose or flash paper is paper that has been soaked in a whole bunch of chemicals, and they soak into the paper, and then we dry it out, and that's why it feels like tissue paper. But those chemicals cause the paper to burn super, super hot. And so all of this stuff that's left when we burn the regular tissue paper, all the ash and the black stuff and the smoke that we saw, stuff like that, that gets burned up. And that was way cooler, wasn't it? Yeah. So just by using a little bit of science and making a different kind of paper, we did something that was way cooler than burning regular paper. So we're going to do that with a lot of stuff. We're going to do an experiment that's going to make it lots cooler. Now, anybody ever seen one of these? What is this? Oh, it couldn't look like Reggie. It's actually bigger than this. It looks a little bit like a lettuce, sort of.
A brain.
Oh, a brain? No, it's not a brain. I don't have a cut up brain here. I heard it over here. It's a cabbage. That's right, this is red cabbage. You make coleslaw out of it. You can eat it in salads and stuff like that. You can find them at the grocery store. We usually use them as food, but we don't have to. No, we can do a little science with it. If you take the cabbage and you boil it into some water and make like a tea, like cabbage tea. Yeah, that doesn't sound very good. But you can use that to do some cool science. And so I am going to need a helper up here who remembers what we call flash paper. Does anybody remember what scientists call flash paper? Yes. Nitrocellulose. That's excellent. Come up here, young man. I'm going to give you a glove. We're going to play with things called acids. Yes. Oh, he smiled. You should have seen it. I said we're going to play with acids. That makes me a little afraid of him. What's your name, young man? Hudson? I'm going to have you hold that tube in your gloved hand there. I'm going to put some water. This is not acid. This is just water. I'm going to fill up the tube. I don't know. A little more than halfway, maybe. So, oh, it's not. Yeah. All right. Now this is my cabbage tea. Ooh, gross. Now, if I put this in here, Hudson, we are going to have what scientists call an indicator. Anybody know what an indicator might be? when I say indicate what smells like cabbage? Alright, stir that. This thing again. Yeah, just, you have to stir it real hard. We'll mix it up a little bit. Excellent. So Hudson is mixing up the cabbage juice into the water. So we're going to have an indicator. Indicators mean they tell us something. But what is this going to tell us? Yeah, what do you think?
I forgot.
Oh, that's okay. What do I have here? Hudson? Vinegar. Excellent. All right, that is probably good. I'm gonna add some vinegar. We're gonna observe this though. I'm gonna make it a little bit darker, just so we can see it. It did turn purple. I'm gonna make it a little darker purple so it's easier to see. It did. So my water is now purple, right? So we're gonna add. Let me get that back together, Hudson. I'm gonna add some vinegar to it. I'm gonna hold it right out here, maybe in front of my lab coat a little bit so people can see it. Excellent. If I add some vinegar in there, what might happen to this purple cabbage water? Oh, I hope not. It could explode though. Maybe. That way your eyes will be okay too. We'll all be dead, but our eyes will be fine. All right. You don't know what will happen. All right. Well, we should just do it and find out. It did. It's not really purple anymore, is it? Yes, like pink. So it actually changed the color. Now, I have something else here called sodium hydroxide solution. Sodium hydroxide, it kind of looks like table salt, but we've dissolved it in a whole bunch of water here, so it's a sodium hydroxide solution. What might happen if I put this in there? Explode!
This place has memories, including us.
No, I wouldn't do that. No, it's not. No. I don't know. It might explode a tiny bit, I suppose.
Turn it back purple.
Oh, it might turn it back to purple. All right, we're going to do an experiment. We're going to figure this out. I put some sodium hydroxide solution in. It did. It didn't turn it back purple. It turned it a whole different color. Excellent. So, what do you think's going on, Hudson? Ooh, I like that. Say that real loud.
Chemicals are mixing.
The chemicals are mixing. One of the ways we know that there is a chemical reaction going on is there's a color change, just like Hudson said. It did. And in fact, what's happening is cabbage juice is what we call a pH indicator. pH means how much acid is in something. Who's ever heard of an acid? Yeah. Yeah. Can you give me an example of an acid all the way down here? What's an example? Do you know? Or what an acid might do? No, that's okay. It's okay. Yeah, what do you think? Oh, that's all right. Yeah.
To make when you're doing like baking soda volcano, it makes it explode.
Exactly. Vinegar is an acid. It's a weak acid. We use it in salad dressings and stuff. There are strong acids like battery acid and hydrochloric acid and sulfuric acid, which would like eat through my shoes. Yeah, so there's really strong ones. Or there's weak acids like vinegar and orange juice. And when something is acidic, that means its pH is less than 7, it turns these colors. Purple. If it's really acidic, maybe that pinky color we had. If it's super, super acidic, it turns bright red. Or the opposite of an acid is what we call a base. Bases are used in a lot of cleaning solutions like toothpaste and oven cleaner.
Like a cylinder. And a cube. And rectangular prism.
Oh, yeah, well, those are good shapes. Like the base of a shape. That's not quite what we're talking about, but that's a good mathematical definition of base. You can see that pH that is more than 7 means there are basic solutions like this sodium hydroxide turns blue and green and then a really light green. So we can use cabbage juice not just to eat, but to do some science to tell what kind of materials we're working with. Excellent, thank you very much, Hudson. Give me my hand. And you can throw my glove right in that bag right there. I'm going to put this here. I don't trust myself. I'm sure I will run into that at some point. Excellent. Now, somebody said something about acids and bases and volcanoes. Yeah, I should come up here. So, we have some acid up here, some vinegar. We have some base, some sodium hydroxide. We're not going to use this. What's your name? Rollins. Excellent. Rollins, I'm going to give you a glove as well. Excellent. We're actually going to make that volcano that Rollins was going to talk about. Yeah, so we can use the acids and bases not just to change the color in the tube, which is pretty cool, but we can actually release some energy and make a volcano, which we're going to do right here. All right, I am going to put some vinegar in here, Rollins. So hold on to that. Now the base we're going to use is something else we all have in our kitchen. We all have white vinegar in our kitchen. We also have this. This is a powder. This is baking soda. Sodium bicarbonate. This is also a base. So when we mix an acid and a base together, do they react? Yeah, we saw that it can change the color if it reacts with an indicator. When acids and bases react with each other, they release a whole lot of gas and heat and some other stuff too. They actually take in heat. But they do a good amount of reacting. This one is going to make a tiny volcano for us. We're going to make it right in this. If you'll come around behind the table so we're not blocking anyone here. Come around here. I'm going to add, I think 2 teaspoons of baking soda right in there. Like this. Excellent. And see if we can make a mess. So when Rollins pours that vinegar in there, it's going to mix. The acid and the base are going to create a whole bunch of gas, and we should see some bubbles. We should maybe, hopefully, see a little mess in this pan. We'll see how that is. All right, so pour it right in there, Rollins. Yep, right down the middle. Oh, not nearly enough. We are. I got lots of vinegar and baking soda. It's a giant clump of baking soda in here. Alright. We should have a tablespoon. This version. This. We'll put 1 tablespoon in there. That's what. We'll put a tablespoon in it. What's a teaspoon? We'll do that. Alright. This time we'll go with 60 milliliters. All right, let's do it. That's okay. We're gonna make a bigger mess than that. So we have a volcano. You can do that at home and make all the mess you would like, or all the mess your parents would like you to make. I would do it in a pie pan or a little trash bag. Give Rollins a hand for making a volcano up here. So again, that was tiny. You only got up to you didn't even get all the way up to the nozzle. So I said we're going to do things bigger as we go along. So that was a tiny little volcano. We are going to make a little bigger chemical reaction, it's going to release some more gas. We're going to trap them a little bit in some foam so we can make a bigger mess. And I need someone who can tell me what the opposite of an acid is. Raise your hand, tell me what the opposite of an acid is. We'll go all the way down here. What is the opposite? What's the opposite of an acid?
Bacon.
Oh, that's okay. Let's see. We'll go all the way down here. Let's see. What is the opposite of an acid? A base. Did you know that? You did know that. Come up here. That's awesome. What's your name? Say hello to Annabelle. Yeah, all right, now Annabelle, we used acids and bases. We're going to use a couple of different things here. This kind of smells like bread, doesn't it? Yeah, it smells like baking bread. This is yeast. Yeast is the stuff that makes bread rise. And it's actually little tiny living organisms. And what yeast does, yeast eats sugar. That's what it does, that's how it lives. And then when it's done eating the sugar, it makes a lot of gas and other byproducts. And we're going to use that with this. Now we're going to put on some gloves, right, before we use this. And we're going to put on 2. Because we might splash this. This second ingredient that we are using to make this chemical reaction. You can take that. Here, I'll put it to the side so we don't get it messy. All right. We're going to put that, let's see, up right there like that. These are huge. Excellent. We're going to put one over here. Awesome. And I am going to put one on too, because I don't want to get this on me either. This is hydrogen peroxide. Has anybody ever heard of hydrogen peroxide? Yeah, what is it? We have it in our medicine cabinets. Yeah. Oh, hydrogen peroxide is not an acid. It does bubble up though, kind of like our volcano. When we put it on our cuts to clean them out, it's the stuff that bubbles up when it's cleaning our cuts. Oh, it's so tiny for me, Annabelle. Excellent. That's 3% hydrogen peroxide though. This is 35%. This is the stuff they use in hair salons to bleach people's hair. So yeah, like when if somebody wants to be a platinum blonde or something, they put this on. If we get it on our skin, it'll bleach our skin and make it itch, so we don't want to do that. All right, Annabelle, are you ready? Hydrogen peroxide is H2O2. Like water is H2O. Hydrogen peroxide has a little extra oxygen molecules in it, and we're going to separate them with the yeast. The yeast will separate all of the hydrogen and the oxygen in here, and we're going to make a little bit of a mess, all right? And you are going to be the person who creates the mess, okay? All right, if you come around to the back here, be right there, we'll go up to the table. Yeah, I am going to put a little bit of this hydrogen peroxide in there, okay? Yeah, I'm going to put a little bit of that in there. I'm going to put like 30 milliliters. And then I'm going to put a little bit of soap in there. And then what I want you to do is you are going to dump all of that yeast in there, okay? After I put a little bit of soap in there. All right. 3, 2, 1. Yep, dump it all right in. Excellent. Oh yeah, we're gonna make a mess. Wow. Okay, if you take one of your gloved fingers and you put it right in there, can you describe how that feels? It does feel hot, doesn't it? Yeah. Oh, don't get too much on because we don't want to get this stuff on our skin. We're going to have to take off our gloves pretty carefully, okay? Excellent. We should do that right now. I'm going to show you with this one. We take a glove off, we take it like this and we pull it all the way past our fingers so all that nasty stuff's on the inside. Do it right down here. Right there. And pull it all the way past your fingers. Perfect. And then you throw that right in there. And then you take the other one off just like that. Perfect. Give Annabelle a hand for making a mess. That was a bigger mess than the volcano, right? Yeah. So, we've seen some things that we started off with one thing, like we used a cabbage, which we could eat, then we used a chemical as a chemical indicator, an acid-base indicator, and then we used acids and bases to make a tiny volcano. And then we made a really big mess using the yeast and the hydrogen peroxide to release even more gas. So we've gotten a little bit bigger as we've gone on. I want you to think about how you might even use something else or more of the same things to make larger experiments. And what might you be able to do besides make a mess with it? You might be able to do some work with it. Or you might be able to clean something with it. I don't know. So I want you to think about what you might do to make these experiments even bigger. Now, what do I have here?
Bottles.
I do have bottles. I do have balloons on it. Now, I need someone with a lot of hot air. Let's see. I have a ton of hot air. Okay, you look like you have a ton of hot air. And, yeah. Excellent. All right. Let's see. Which one of you has the most hot air? Yep, okay. I won't argue with that. All right, so what I want you to do is see this balloon in here? I want you to put it right up there, and I want you to blow up that balloon. Just blow it up. Oh, hold on. Look that way. There we go. Yeah. No, that's not working. Yeah. Oh, stay here. That's hard, isn't it? That didn't blow. That hardly blew up at all. All right, you think you can blow this one up? Yes. Oh, she's very confident. Oh. Hold on. I should have pulled these out to begin with. All right. So. Baby wipes. Well, I might have to try to blow this up too, so I'm gonna. Maybe. Come on. There we go. All right, hold on. I'm going to try to blow this one up. We're going to find out what happens. I'm lots bigger than you. I think I should be able to do it. I can't do it. Why do you think? Anybody know why we can't blow it up? Do you have any ideas?
There's nowhere for the air to go inside the bottle.
There's no room for the air. There's all kinds of room.
No, there's air in the bottle that can't escape.
There's air in the bottle? I can't see it.
I can't see it.
Who thinks there's air in the bottle? Even though we can't see it? Alright, hold on. Alright, let's see. Why do you think I could blow up this balloon? Yes.
Because there was no air there. The air release.
Oh, that's very close. There actually was air in this bottle, but what's there? There's a hole. There is a hole in that bottle. Now, you think there's air in there? No? Yeah, I think there's air in there too, because I just put this balloon on there before the show. There's already air in there. But air actually takes up space. It can take up the space of this bottle. Actually, we can feel the pieces there. We can't see them. It's invisible. I was joking that we couldn't see it, so there might not be air in there. But we can feel those pieces of air when we wave our hands around.